My name is Peter Asmus, and I'm the Director of Strategic Marketing here at AutoGrid. And we're having now another episode of On the Grid Edge. I'm very excited today to have Bala Vinayagam, sorry, Bala, head of Schneider Electric's microgrid offerings globally. So Bala, welcome, and why don't you give us a little background on yourself?
Thank you so much, Peter. Very happy to be on the show. I know this is a very popular show, actually led by you. I'm very happy to join you today and contribute actually to this episode on microgrids and VPP. Just a quick background about myself. I've been an engineer by profession, so been in the field of automation for the last 20 plus years, primarily focused on automating the grids, protection control, automation, and monitoring. Serving this industry for the last 20 years, both utility side automation and the industrial side automation as well. Recently, 6 years I've been with Schneider Electric and focused on the digital backbone for the energy management business, as well as in the last 2 years, been part of the microgrid business.
Sure. So, um, you and I both, as we look out at the world, I think one of the big trends and why we're talking about both microgrids and virtual power plants is just the growth in distributed energy resources and how we're becoming more and more dependent on them. But in order to sort of make that work, we need kind of organizing platforms, controls, as you say. So, how do you see the world? Let's say, I don't know, you started with microgrids a few years ago. When you look at the global landscape today, what really stands out to you? Like, why is this now really seeming to gain a lot of traction? I mean, it's been gaining traction slowly, but it seems like it's kind of starting to explode. Why do you think that is?
I think there is definitely the electrification of the world is very important for us to really reach that targeted goal that we want to have actually on the 1.5 degrees Celsius. I think having the infrastructure electrified will take us faster towards it, in
Hmm.
my opinion. And there, the grid of the today cannot serve actually the deep electrification and the deep decarbonization that is going to come in the future. I think this is where I strongly believe that the unidirectional power flow of bulk generation, bulk transmission, radial distribution, needs to change actually to really look at the bidirectional flow of energy back from the demand side as well. I think this is going to be very important, in my opinion, as we continue to, electrify the fleets and electrify the buildings. Just as an example, right? Like, we are today in the U.S. Has an installed capacity of around 1,200 gigawatts,
Hmm.
and US has a goal actually to uh, not only decarbonize but also electrify the fleets and the buildings, and it will take another 1.2 terawatts. That is, we mean to double this capacity in the next 15 years time. It took us like almost 70, 80 years actually with 7,000 power plants to get to where we are today, and
Right.
we need to make that happen in the next 15 years, and that cannot happen with the way the grid has been operating in the last 60, 70 years for us. I think this is where the distributed energy resources penetration on the demand side and their participation to help accelerate the future of this grid and the deep decarbonization will be an important factor to consider. And that's
Definitely.
where, go on.
Oh no. Um, well, maybe we should define a little bit. So I mentioned microgrids, virtual power plants. I remember when I first started looking into microgrids in a deep way, like back in 2009, the terms were sort of used interchangeably at that point. People were kind of starting. I mean, there is a government definition of microgrid, not so much virtual power plant. But in your mind, how do you distinguish? I mean, I have my own way of distinguishing, which I guess I can say very quickly. Like microgrids is a static set of resources, combined boundaries, can actually island or maybe permanently island, as you're in the global market, where actually most microgrids, there is no other grid. There's just a microgrid. Whereas the VPP is more sort of it's easier to think like kind of a demand response is kind of where it started in the US, and it's kind of temporary aggregations that meet the needs of the market in real time. But I mean, that's the way I view it. I was curious, how do you look at it, or what kind of trends do you see between this microgrid VPP synergy we talked about in that blog?
So I think there is, as you said, there is many different definitions depending on who you talk to. Everybody has their
Yes.
definition of the microgrid, and the way in Schneider we were looking at the microgrid is a bit more from being the definition of boundaries, whether it's in front of the meter or behind the meter, whether it can island itself or it can be grid connected. We were looking at an outcome based approach actually to this one. If we really need to have a behind the meter distributed energy resource penetration to come on board, what would actually this microgrid should look like from an outcome perspective? So we were looking at you know customers who want to really reduce the cost of the energy,
Hmm.
or customers who would like to actually have their DERs participating in the market
Right.
in a for demand side flexibility programs, and
Hmm.
customers who would like to have actually the same infrastructure to help them actually provide a resilient and backup power.
Yeah.
And while they build these two outcomes, can they really have them as a decarbonized green infrastructure?
Hmm.
That we consider actually as a microgrid behind the meter,
Hmm.
that can be grid connector, or that can be islanded, or it can be a completely off grid last mile non-wire alternative as well.
Sure. Um, Now, one thing about microgrids, and we talked a little bit about this when you and I were at Microgrid Knowledge, is, they used to say, you've seen one microgrid, you've seen one microgrid. It was kind of the
Right.
thing, the whole beauty of the microgrid. It was a totally customized solution just for you. And, but it would, and so that's the positive side. Okay, you can, whatever. I guess I don't know if it's a negative, but the challenging side is that means each solution is customized engineering that's going to take a little more time. But I know Schneider, you've been a leader in this idea. I guess you could call them more modular, standardized. So talk a little bit about that. How did you come to that sort of, I guess, uh, realization that maybe that might be a better way to go, or at least another alternative? Let's put it that way. Yeah.
You're right. Actually, I think each microgrid, what we used to call them as snowflakes, right? Each one of
Yeah.
them are very unique
Yep.
in their own ways, customized. I think it was good actually to really understand what it would take us to know what a decentralized, distributed, power plant will look like actually behind the meter. I think in the last, I would say like 15, 20 years, we have been experimenting quite a bit actually on understanding what would take for us to deploy the solution and really prove the use cases and the outcomes. But I think at this stage, if we need to really go from these tens of microgrids or hundreds of microgrids, can we really go from these tens and hundreds to thousands? And even I would challenge ourselves to see like why not millions actually, behind the meter as we consider buildings, as we consider EV fleets. I think the chances of actually this happening in the near future is very bright actually. So when we look at this massive proliferation of or adoption of DERs behind the meters need to happen. It cannot be snowflakes every time. It
Right.
needs to be standardized. And here we looked at two different types of standardization. That's one we call as a horizontal standardization. What would take for us to really build the building blocks that stacks one above the other, right from the DERs to the electrical distribution, that orchestrates the coordination between the loads and the sources, and then about power management, and then energy management. And how do we really, integrate this energy management with even VPPs actually to make it much more simpler and easier actually for this adoption of these different bricks. And that's we call as a horizontal standardization, which means that each of these bricks should be modular enough that can scale from something like a 50 kilowatt microgrid to all the way probably like 3 or 4 megawatt microgrids behind the meter. Then you have the vertical standardization. How do we make sure these bricks that we build actually can also talk to each other? in terms of the physical connection and also the data connection that is required, so that we can really deploy them at scale, profitably actually, and at the least amount of time actually the market to adapt these things. That is how we came with this idea of standardization of the microgrids behind the meter, which will allow this scaling. Not only the scaling happen just by having Schneider Electric, deploy the solution. That's probably for sure. But also we want to look at how do we enable this for the other, market players. How do we make it viable actually for solar integrators? How do we make it viable actually for electrical distribution contractors? How do we make sure that the microgrid builders actually can scale this one? And how do we make sure that we can standardize these for the energy as a service players? So we looked at the different market actors and the personas, and we decided on having this standardized approach that will allow us to truly move from these hundreds to thousands to potentially actually millions in the future.
Yes, and I think, I mean, there'll always be the snowflakes, as you would say, for larger, more sophisticated systems. Like some college campuses can be a 40 megawatt microgrid, a 60
Right.
megawatt. But I think what we're talking about are a little more on the smaller end, where we want, especially smaller CNI, or, for example, a lot of commercial and industrial facilities do have similar sized buildings. So I think that's where it makes a lot of sense if you kind of have a more standardized system with a, you're just reducing the amount of customization. And I know there's other players out there, in the Schneider ecosystem of solutions that, maybe have certain assets that almost have to be in that microgrid, but there is some flexibility. So I think that's what you're talking about. But so when we kind of standardize the hardware part, then this is kind of where the VPP kind of concepts, the artificial intelligence, then more of the customization, and this is where AutoGrid and Schneider are now integrating platforms, where the customization actually, at least this is the way I've looked at it, and curious to see, comes more on the software side, where that's where you can kind of fine tune things, or what's the main purpose? Is it decarbonization? Is it cost savings? Or you could even shift the purpose depending on the moment, like whatever, a power outage could happen. Let's go into resiliency mode. So that was a long question, but um, is that how you look at it too? What's like the role of AI and software in this whole kind of solution?
Agreed. I mean, listen. I mean, this is we know that actually, like the bulk power system is very complex, right? We
Yep.
know hundreds of thousands of constraints and different set of rules actually comes together to really have a balanced, load and source. Depending on capacity market, energy market, intraday market, wholesale electricity prices. We know all these different types of economic or power system constraints that need to be arbitrated. Now, we are talking this at a 7,000 power plants and probably like 50,000 substations, right? And now think about what we just talked about in terms of having these behind the meter CNI infrastructure that runs into thousands and potentially into millions. I think this is where the AI has a very, very important role to play. I think the first and foremost role that AI will play is also like how can we now optimize these resources to deliver the right level of customer outcomes for which it has been designed.
Right.
Has it been designed actually with saving the energy cost? Is it more self-consumption? If the source has got solar and storage, like when to charge the batteries, when to discharge the batteries, all of them are not simple decisions. I think they require a ton of data. They require actually forecasting, and that requires actually a sophisticated level of optimization. I think the AI will allow us to deeply optimize to deliver those outcomes. This is like one microgrid we are talking about. Now, as you keep adding more constraints from a market perspective with real-time pricing signals coming in, and then the flexibility market actually opens up actually for these microgrids to participate, the situation changes. I think AI can come in and continue to help actually streamline, very deeply. I think this is what actually, if I understand, both the advisor platform of Schneider does, as well as actually the VPP platform of AutoGrid does. I think you are looking into now. I'm talking like single microgrid behind actually a meter. Now you are talking about from an AutoGrid Flex perspective. Now, how do I aggregate like thousands of them in one city to probably spanning a state to spanning actually a region? I think
Right.
AI will come in and serve the deeper purpose of actually allowing these flexibilities to be open up actually for these markets to take care of many different types of requirements. And in that process, Peter, can I ask you a couple of questions on this one, right?
You can ask me. That's right. You're turning it around. Sure. Ask me a question. Sure.
So tell us more about how the AutoGrid Flex platform is helping shape the future of what we are talking about: microgrids, VPPs, and actually the DERMS.
Yes, well, I mean, I started my research more on microgrids and kind of migrated to VPP. And actually, I'm pretty excited that they are coming. They're very complementary, I would say. But the AutoGrid Flex, I think the way I look at it is the VPP model is really driven by dynamic pricing, price controls, and real-time optimization, like old school demand response. Someone used to call up a cement plant on the phone and say, close down between 1 and 3 because there might be a shortage. Modern, more, VPP is real time. It could be demand, could be a battery, could be an EV charger, water heater, doesn't matter as long as you can sense it, control it, optimize it. And so bringing that kind of technology to a microgrid that enables these microgrids to each individual microgrid to optimize more on the bill savings part, so it's more, which of course is what's going to attract people's attention. People do want to reduce emissions, but in the end of the day, people also want to save money, and stuff like that. So you can do both and you can optimize, as we were saying earlier. So that's kind of the way I look at it. But the most exciting thing, and we wrote, I helped put together a white paper that Schneider published, is this idea you got to call them federations of microgrids. So just like I actually just got a solar battery system installed last Friday, right before Independence Day. So it took me forever. So now I know what people have to go through for permitting. But that whole idea that now I, as an individual home, could become part of the VPP that AutoGrid software will manage. And I think the vision is all these microgrids, which already have the DER assets sort of balanced in the microgrid itself, and then you can aggregate these fleets of microgrids. I think that is the most exciting opportunity because it's going to blend resiliency, it's going to blend, economic savings, and it's going to support the grid. So some utilities historically have been sort of leery of microgrids. They don't control them necessarily if it's not deployed by the utility. And when will they island? When will they not? Well, this kind of incorporation kind of turns that around and saying, actually, these microgrids support the larger grid, but also offer resiliency. So that was a very long answer to your question. But, that's the way I look at it.
And just to more elaborate on this part, we talked about microgrids participating in these flexibility markets, right?
Right.
I just came from my visit with Spain, actually, where the regulations are still shaping up, and the incentive plans are still shaping up. I'm sure in the US, I think we have a much more stronger regulatory environment and an incentive environment. As the in front of the meter has a deeper penetration of solar and storage, or solar and wind, actually, okay, not storage yet. We will continue to see that there is a big shift in the market itself, right? Like we will start to see a flexible generation and a rigid load, forecasting, which is almost like fixed forecasting, because we assume actually what the load is going to look like for foreseeable future, and then we take the flexible generation and dispatch it, right? And this model is completely changing because now you can't call your nuclear or fossil or natural gas and other sources that you have been very good at calling and dispatching them as the need arises to something that is completely indispatchable, right? Like or minimal dispatchable. Let's call this way, actually, right? The
Right.
solar and the wind, and this is where the flexibility comes into play very deeply to help actually this intermittency that will come in front of the meter, right? And I strongly believe that demand side flexibility, that is required to unlock the deeper integration of solar and wind in the main grid is an important parameter that's going to be enabled by the VPPs, because the VPPs will now aggregate and help actually provide this flexibility and provides another revenue source, actually, in fact, for customers. I'm pretty sure you would have probably been reading in the news and everything. The last few weeks time, some of the customers, residential customers, were able to sell their battery capacities back to the market in some of the states at like somewhere around 230 cents per kilowatt hour, while they're buying the power at 14 to 20 cents,
Right.
right? I think these are some of the things that are super important as we continue to see this deeper penetration of solar and wind and the deeper decarbonization.
Yeah, no, I agree. I mean, I think I remember I used to, before microgrids, I was more into wind. I wrote a book about wind power actually, but I remember at the time, and this is like 20 years ago or more, where people would say, well, of course, we can't go above 10% wind. You know, no one did a study. It was just sort of this thinking that it's so variable. But obviously, now we're going to go way beyond that so that we actually kind of flip around the way we look at the grid, where we let the renewables sort of lead the way, you know, as opposed. And the other thing which we haven't brought up is in the past we would use a fossil peaker to fill in that gap when the wind would die down or whatever. And now the beauty of the VPP is you can displace most of those fossil peakers over time with just aggregating these cleaner distributed energy assets, and therefore you don't have to kind of negate some of your emission reductions from the renewables by then filling in with fossil peakers, which generally are pretty highly polluting and actually pretty expensive. So that's the other beauty of this whole thing. Well, before we want to go, I wanted to just talk a little more specifically about this integration, which we're calling Flex. So I guess AutoGrid had a Flex platform, and then you guys stole our. No, I'm just kidding. But then you, Schneider, you're calling this. So let's talk a little more about this specific product, Flex. We kind of have talked around it a little bit, but in your own words, it's more standardized. It's incorporating the AutoGrid platform. What else would you want to say about this new platform, and when will it actually be out there in the market, actually, delivering and being deployed?
So as we speak, actually, the we have opened actually, we launched this product actually back in the Microgrid conference, and we are
Yes.
ready to take orders, and we are almost starting to see actually quite a lot of engagement with different, market players already, talking about and engaging with us on this one. So just as a recap, like the Microgrid Flex we are talking about is truly enabling behind the meter standardization on the electrical distribution and the power management, the energy management, and the enterprise connectivity into the aggregation platform of AutoGrid. So what we are enabling for customers is to, simple plug and play systems that they don't need to sweat in order to, make the adoption of these behind the meters DERs in a scalable way while delivering actually a ton of these use cases. So you don't need to have engineers working and sweating their time designing what it needs to be. Instead, you're making it much more simpler. With this Flex platform. Good thing is that you have an AutoGrid Flex, we have a Microgrid Flex. Flex comes together and flexes the muscle to give a much more standardized solution to the marketplace.
Yes, no, no, well put, succinctly said. So I guess before I let you go, now you have a global perspective, as you said, and it's sort of. I'm just curious when you look at the world market, different regions, and we're talking about VPPs and microgrids. Which part of the world are you most excited about for future maybe it's the whole world. He says is exciting, but I'm not putting you on the spot. I'm just curious, like, is it Asia Pacific, is it Europe, is it Africa, wherever. Where do you see Flex? In some ways, I would imagine the new Flex product, probably the U.S. is maybe number one market, but I don't want to put words in your mouth, so I'll let you answer my question, my long
I think if I go in the future, actually 20 years from now, I'm pretty sure actually all over the world, right? I think the energy needs of the world needs to double. There's not a lot of real estate left actually for us to have the traditional way of power generation and transmission. I
right.
think the distributed, decentralized, infrastructure is going to be a pivot actually in order for us to go to the future that we want to actually purely from the perspective of climate change goals that we have. Right. I think that I'm super excited. And most every country need to embark on this story, actually, in my opinion. But in the short term, like, when we look at the next 2 to 5 years time, I clearly see that US is probably one that has got all the elements checked. Actually, I think there is a great regulatory environment, and there is a great incentive program. The coming together of these two things actually is what actually giving us the confidence that we can scale the flex in the US market substantially. But we also see that Europe actually has been fast tracking on this subject, because they have both building electrification and actually the fleet electrification story, and they have their own deep decarbonization story that they have from a grid perspective. So you look at Germany, you look at Spain, you look at Nordic. We are excited about actually the markets over there, as well as they continue to push the boundaries on the regulatory environment, and then embark on a similar story like US on the incentive programs. I don't see a reason why Europe actually cannot actually jump into this growth engine on the microgrids in the next 2 to 5 years time. I also see Australia is very similar to the US. I think Australia is probably one of the front runners as well, both in terms of the regulations and the incentive programs. But what's also interesting is that the off the grid market, which is also a microgrid, what we call, actually, is picking up very deeply in Africa, in India, in Southeast Asia, in island nations. We continue to see microgrid being talked about as a last mile non-wire alternative, even in the short term. So I'm super excited that there is a bright future for the microgrid story. But in the short and the midterm, I clearly see that 5 to 10 countries will probably give the most important growth actually for us globally.
Okay. All right, Bala. Well, thank you so much for joining. We could talk forever, but I think we'll wrap up here. So thanks so much.
Thank you so much, Peter.
Okay.
Bye bye.
Bye.